Okay, so for this, this may look more complicated, but it's this that we can do more stuff with immediately because they're compounded angle formulas, right? They're compounded angles, so we can apply the compound angle formulas. So that right there is the sum of the tangent x and tangent y over 1 minus the product. That's the formula. Similarly, now it's a difference on top, the 1 plus. Okay. Note that these two are conjugate pairs. So if you multiply it, right, it's a plus b, a minus b form. So you get a squared minus b squared form when you multiply it. So you get tangent x squared minus tangent y squared. Similarly, at the bottom, it's also difference of squares. 1 minus this and 1 plus the same thing. So you get 1 squared minus tangent x squared times by tangent y squared. Now, on the other side, okay, first of all, note that now we have it in a similar form. It's a fraction with two terms, top and bottom. But we want to convert the tangent to sine over cosine, right? Because that's what's on the other side. Okay, so let's add the top, and you get a common base of cosine squared x, cosine squared y, and you get sine squared x times by cosine squared y, right? Cosine squared x, sine squared y, all over. Okay, if you combine this, you get cosine squared x, right? Cosine squared y minus sine squared x, sine squared y, all over the same denominator. Okay, so if you multiply the top and bottom by exactly this, right, this will cancel out. Okay, and what we have is just this over that. Okay, so let me write that here. Continuing up here. Okay, so we want to get to here. Okay, so we've seen this before. Okay, and a few of the earlier questions, what we have to do here, right? So we have sine x squared, we have sine x squared, but it has this attached. Similarly, at the bottom, it has that attached. But the only thing we know how to do to that, to change in form, is to use the Pythagorean identity. Okay, what goes in that bracket? Okay, and here we get 1 minus sine, right? 1 minus also sine. All right, let's expand. Okay, you get sine of x squared by itself, and then you get a product of okay, so that is what we want. On the other side, we still need just the sine y squared, okay? But from the second two terms, note that that's exactly what's common. At the bottom, okay, note that we want this. That's also common at the bottom as well. So continuing. Let's factor that out. In fact, let's factor out minus sine y squared, and we're left with sine x squared plus cosine. It should be x squared here. Okay, that should be x. That should be x. And it was x right here. Right? So I made a copy and paste error when I got to this step. You can factor out a sine squared y, and you're left with a cosine squared x plus sine squared x. Okay, that and that, of course, is equal to 1. And we're on the right side.